Guys, hello everyone and welcome to the channel. So today from this video onwards I am going to start a new series for the upcoming CSIR-NET exam. This series is going to be called cheat sheet series. In this series we will be having short videos, crisp videos, trick related videos, those type of topics which are actually like from where the questions are asked in exam. So those things we are going to discuss in this series. All right, so this video will be a part of it, in which I am going to tell you that how you can actually find out point group of any molecule in 3 simple steps. Now I don't have to explain this, that point group or group theory is such an important topic, especially when you are preparing for the CSIR-NET exam. And when you study point group, there are so many things to understand, like there are so many things to take care of, that eventually you become like it becomes very difficult to to understand everything at once and to summarize to find out the point group. But today I will just give you 3 steps. In those 3 steps you will be able to find out point group of most of the molecules and few tricks which will help you to find out the point groups of the remaining molecules. All right, so let's start with it. Let's have a detailed video on it, and let's try to understand all these tricks and how to do the questions. We'll have a lot of practice of questions in this video as well. All right, so let's get started. Before jumping into the trick part, before going into that, there are certain types of molecule whose point group are pretty well known. Okay, they are like very easy to understand. For example, linear molecules. Okay, those molecules which are linear, just in a single line you can draw them. So these type of molecule can be of 2 types, right? They can be either like symmetric. Symmetric means they are totally like on both the side, you can actually bisect them into 2 equal halves, and they can be easily bisected. And then you have asymmetric linear molecules. Now asymmetric means you cannot bisect them into equal halves. Symmetric molecules, for example, you have any homonuclear diatomic molecule, any homonuclear diatomic molecule like H2, N2, O2, all are examples of these symmetric molecules. All right, then asymmetric molecule, any diatomic heteronuclear molecule, like for example CN, NO, these are all example of asymmetric molecule. Now symmetric molecule can also be like it can be a 3 or a polyatomic. For example, carbon dioxide. Carbon dioxide, you can see that it's a molecule which is actually symmetrical. It's linear because you can bisect it into 2 equal half through this carbon. Then asymmetric can also be polyatomic. For example, HCN, right? So HCN is a molecule which is asymmetrical because you cannot bisect into equal half. One side you have hydrogen and one side you have nitrogen. Now you have to remember this thing, like if you are dealing with tricks, you have to memorize few things. Okay, so for symmetric, if you have a molecule linear and if the molecule is symmetric, in that case the point group is going to be D infinite H. Okay, this is the point group for a linear symmetric molecule. Any molecule which is linear and symmetric, D infinite H. And if the molecule is linear and if it is asymmetric, in that case the point group is going to be C infinite V. Okay, so now these 2 things you have to memorize, because any linear molecule will have infinite number of rotation, or the principal axis will be infinite. That's why this infinite is coming. So D infinite H for linear symmetric molecule, C infinite V for linear asymmetric molecule. As simple as that. All right, now let's go to the trick and let's see those 3 steps in which you can find out the point group of molecule. Alright, so when you are going to find out the point group of molecule, you just need to look upon 3 important things. First thing is the principal axis. Okay, you have to look for the principal axis. Principal axis will be given as Cn. It can be C3, it can be C4, it can be C2, anything. Okay, it can be C6, anything. N will be the number of fold by which it is getting rotated. Okay, and that is also pretty simple to understand. If you have 3 atoms which are replacing each other, then axis will be C3. If there are 4 atoms which are replacing each other, then it will be C4. All right, so principal axis, just you have to look for that. Second thing which you have to look for is subsidiary axis. Now subsidiary axis, what are subsidiary axis? For that I have made detailed videos. If you want to understand it in detail, you can go there and you can watch that playlist of group theory. There we have discussed these things in detail, but for now you just have to see subsidiary axis, axis which is the axis which is perpendicular to principal axis. That's all. All right. So if axis is perpendicular to the principal axis, in that case it is called subsidiary axis. And which subsidiary axis actually you have to look for is just C2 subsidiary axis. No other subsidiary axis you have to look for. Okay, you just have to look for C2 subsidiary axis. So you need Cn principal axis, and you need to look for subsidiary axis which should be C2, and these subsidiary axis will be perpendicular to the principal axis. Don't worry. If you are getting confused, don't worry. I'll give an example and we'll make you understand with that. So for example, let's say that we have this BH3 molecule. Okay, so we have this BH3 molecule. All right. Now the principal axis for this molecule is going to pass through this boron, and this is going to be a principal axis, and that will be your C3 axis. Why? Because 1, 2 and 3 hydrogens will replace their places. All right, they are going to replace their places. That's why it is a C3 axis. Now look for the subsidiary axis. Subsidiary axis should be perpendicular to this. Is there any perpendicular axis to this? Yes, there is a perpendicular axis, which is this, and this is a C2 axis, which is actually going to replace these two hydrogens from their place. Similarly, you have one more C2 axis which is going to replace these two hydrogens. Similarly, you have this C2 axis which is going to replace these two hydrogens. So by far now, I hope you understood what is principal axis and what is subsidiary axis in short. The third thing which you will look for is a plane. Okay, now plane can be of two types. Plane can be either sigma h or it can be sigma v. Sigma h and sigma v are very simple to understand. Sigma v is a plane which will be perpendicular to principal axis. Okay, and sigma v will be the plane which will be parallel to principal axis. Okay, parallel to principal axis. So these three things you have to see. That's all. Principal axis, subsidiary axis, and plane. Now you have to combine the data and then you have to find out the point group. See how simple it is. Okay, so let's say you have a principal axis. Okay, you have principal axis, subsidiary axis, sigma h and sigma v. Okay, so let's make a quick table and we will just write down everything with respect to that itself. Okay, whatever we have, I will make a tick on that. Whatever I don't have, I will make a cross in front of that, and what will be the point group, that I will explain you. So let's say, of course, principal axis will be there in the molecule. So you have a principal axis, you don't have a subsidiary axis, and you have a sigma h plane. Okay, and let's say sigma v is also there. It happens or it does not happen, it doesn't matter. Sigma v is there or not, it does not matter. If sigma h is there and principal axis is there, but there is no subsidiary axis, in that case the point group of this particular molecule is going to be CNH. Now n will be the order of principal axis. If it is a C3 axis, then it will be C3H. If it will be a C4 axis, then C4H. If it is a C2 axis, then C2H. Okay, so condition is you should have a principal axis, you should not have a subsidiary axis, you should have a sigma h plane, and sigma v doesn't matter. If it is there or not, it doesn't matter. Okay, these two things are which you have to look for. Now let's see the next thing. Okay, or the next condition. Next condition is that you have a principal axis, and let's say you don't have subsidiary axis, you don't have sigma h. In this case, you don't have sigma h, but you have sigma v. Okay, if this is the case, in that case your point group is going to be CNV. Okay, so that means what you have to look for is just sigma, just principal axis and sigma v, and also you have to see that the sigma h should not be there. So I am just circling out whatever is the necessity thing to get that particular point group. Sigma principal axis, sigma h not present, sigma v present, in that case CNV. Okay, the next one is just you have to look for a principal axis. Okay, let's say the principal axis is there. We also have subsidiary axis now, and let's say again I have a sigma h. Now if it is there or not, it doesn't matter. Okay, sigma v is there or not, it doesn't matter. Just only these three things are there. That means you have a principal axis, you have subsidiary axis, and remember that subsidiary axis won't be just one, there will be more than one subsidiary axis, but fine. Actually, the number of subsidiary axis should be equal to the order of the principal axis. But when you are doing question, let's say you are not looking for that complexity. Okay, principal axis, subsidiary axis, sigma h. These three things if you have in the molecule, then the point group becomes DNH. Okay, whenever you have principal axis and subsidiary axis, your point group shifts from C to D. That's the easiest thing to remember. And at the end, the last combination is that if you have a principal axis, you have subsidiary axis as well. Let's say you don't have sigma h, but you do have sigma v. Okay, so let's say if you have this combination in which you don't have sigma h, but you have sigma v, in that case the point group becomes D and D. Now I know factually I am little bit incorrect because I am not explaining about the dihedral planes. I am not talking about what is a dihedral plane and the presence of that, but for the tricks, for the trick perspective, or you can say for the sake of the exam, this is what you can follow and you will always get the correct answer. Why is it so? Because sigma v and sigma d, okay, sigma v and sigma d are actually not different, they are same. Sigma d just has one more property, that it bisects two subsidiary axis, but here we don't have to look for that. Sigma v is there, then it is fine. Okay, and one more thing which makes this trick more useful, or you can say that whatever we have discussed in these four, is that there is nothing like C and D. You are never going to get any point group like C and D, nothing like that. Similarly, you will never get D and V. Okay, D and V point group you are never going to get. So these type of point group does not exist. C and D does not exist, D and V does not exist. This is the table. If you follow it, you will be able to do like majority of questions. Okay, only linear molecules are different, and then there are certain special molecules. For example, you have allenes, then you have molecules like tetrahedral molecule, octahedral molecule, which have perfect geometry. So those molecules have separate point groups, like methane molecule will have tetrahedral point group, then SF6 molecule will have octahedral molecule. Those are separate type of molecules, but majority of the molecules you will be able to do using this particular trick. All right, let's take example and let's try to see whether whatever we have discussed in this trick, or whether we can apply this trick on those questions or not. I'll be taking some previous year's questions only, all right, so that we can look upon them. Okay, so I have taken these three questions which were asked in June 2014, December 2015 and December 2018. I'll try to show you with the help of those tricks that how you can solve these questions. Okay, so the first question says that find the point group of propyne molecule. So whenever you have to do any question from group theory, you have to understand VACPR theory, you have to understand the structure of the molecule, you should be able to draw it. Okay, so a propyne molecule is nothing but CH3 C triple bond CH, right? This is what we have as a propyne molecule, but this is not how you are going to see it, or this is not how you are going to, it looks like a linear molecule, right, for now, but you have these three hydrogens as well. That's what you have to take care of. So this will be drawn like this. So you will have, this is a sp hybrid carbon, and this will be a single or a linear bond. Then you will have this carbon attached to it like this, and then these three hydrogens. And since this carbon is sp3 hybridized, that's why these hydrogens will be placed like this. Okay, like this. So which axis do you have here? So you can just look upon this molecule as this is a linear thing. This carbon, 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 hydrogen, these all are in a straight line, and these hydrogens are three different groups which are at 120 degrees to each other. It's similar to ammonia molecule actually. If you want to look upon it, it's similar to ammonia molecule, which is drawn like this, right? So this is similar to that. Just here you have lone pair, and here you have this whole thing. Simple as it is, you can simply now tell, but let's apply the rule and let's apply the trick and see. So which axis we have? This is the principal axis, and it's a C3 axis, right? Do we have a subsidiary axis here? Is it possible to have a subsidiary axis? No, we cannot have. There is no subsidiary axis. Okay, so there is no subsidiary axis here. Do we have horizontal plane? So no, there is no horizontal plane. I will just write down everything. Okay, so we have a C3 axis, subsidiary axis we don't have, sigma h we don't have here, And let's talk about sigma v. Do we have sigma v? So yes, we do. Will be having a plane which will be passing in between of, just like we have in ammonia molecule, the one which is passing between of these two hydrogen and passing through this hydrogen, okay, this hydrogen, this carbon, and all these linear bond. That will be one plane. Then the plane going through like this, that means this hydrogen and these bonds, so like that, okay. So we will be having sigma v present. So what will be the point group? C3 is the principal axis and we have sigma v, combine them, it will be C3v, okay. So C3v is the point group for propyne molecule. Very simple. Let's see the next question now. Okay, the next question says that the diborane molecule belongs to which point group? Okay, diborane you have to draw first of all. Again, to do this type of question, you should be aware about the structure of the molecule. All right. So we have in diborane, this is a very specific molecule which have 3 center 2 electron bonds, right? And banana bonds, whatever you call it. So first of all, this is not a planar molecule. You have to understand that all these bonds which I have made by the straight line, these are on the plane, on the screen. This hydrogen is coming out of the screen and this hydrogen is going inside the screen. That's why I have made it, I have made this wedge and dash things, okay. Now let's look upon the planes and all. So if you see here, in this particular molecule, you will have first of all a principal axis. The principal axis will pass through like this, okay. This will be your principal axis and it will be a C2 axis. Why? Because if you rotate it, both the borons are going to replace their places. This hydrogen will go to this place, diagonally they are going to replace their positions. The above hydrogen will go to the below hydrogen place and below will come to the above hydrogen. So the principal axis is C2. This is my principal axis now. Do we have subsidiary axis? So since this principal axis is going inside the screen, I have this axis which is perpendicular to it. How is it perpendicular? See, this pen is right now going inside the screen. This is my finger. If you see, both of them are actually perpendicular to each other. That's how, okay. So this is a C2 axis passing through like this, and again there will be one more C2 axis which can be passed through like this. This C2 axis is going to replace these two boron, this hydrogen and this hydrogen, this and this. So like that you can flip it. So subsidiary axis do we have? So first of all, let's talk about the principal axis. Yes, I do have a principal axis. Do we have a subsidiary axis? Yes, I do have a subsidiary axis. Let's look for the sigma h plane. So I told you that this hydrogen is above the screen, this hydrogen is below the screen, and all the other hydrogens are all this on the screen. So if I join all of these hydrogens, they are going to make a plane. They are going to make a plane in such a way that above the plane you have a hydrogen, below the plane you have hydrogen, both the borons are on the plane and all the 4 hydrogens are on the plane, okay. Where was your principal axis going? Principal axis was going in between of these two borons. So that means ki this plane that my hand is showing right now is actually perpendicular to this principal axis, and that's what makes it sigma h. So it is sigma h. Now you don't have to look for sigma v, whether it is there or not, it doesn't matter. See what I told you, that if you have principal axis and subsidiary axis, that will make it dn. Now principal axis is C2, so this will become D2, and because you have horizontal plane, that's why the point group for this will be D2H. D2H is the point group for diborane. Simple and straightforward. Let's see the next question. The next question here, it says that N2O molecule belongs to the point group. Now this is again very simple molecule. I have to draw the structure of it first of all, okay. So N2O is something like this, okay. N2O has this structure where you have minus charge here, plus charge here, okay. So right now you can simply see that this molecule is a linear and it's not symmetrical, right. You cannot bisect in two equal half. One side you have nitrogen, one side you have oxygen. So this is asymmetrical. So linear and asymmetrical, I already told you in that trick initially that what will be the point group for this. Tell me in the comment section that what will be the point group for this. This is a homework for you. Alright. Now hold on. I'll just give you some notes also so that you can find out point group of some very difficult molecules like staggered molecule, eclipsed, conformations. For them there is a very simple trick which works most of the time. I'll give you that trick as well. One more type of molecules which you will generally come across in exams are staggered or eclipsed type of molecules. But before going into that, there are certain things which you have to take care of. That first thing is that the molecule should not have any substitution on it, okay. So there should be no substitution. No substitution means there should be no, some other molecule should not be there. Like for example, if I am talking about ethane molecule, so it should be ethane, it should not be chloroethane or bromoethane like that. If it is ethane, then it is fine, okay, then you can apply this trick. So there should be no substitution on the molecule, okay. Now there are two types of conformations which you will which they are going to be asked. So conformations which you will come across, first is either staggered, or the other one that will be eclipsed. So whenever you have a staggered conformation, in that case the point group is going to be D and D, okay, that's it. You have to remember D and D point group, N will be the order of rotation of that, okay. So if it is 3 molecules, so it will be D3, D5, so D5, D and so on. If the molecule is eclipsed, or if the conformation is eclipsed, it will be DNH, that's all. So just you have to take care of these two things. For example, if I ask you to tell me the point group for staggered ethane, okay, so first of all you should be able to draw it. Staggered ethane will be drawn something like this, all right. Now I told you that there should be no substitution, so of course there is no other substitution, only hydrogens are present on it. What should be the proper rotation, or what should be the principal axis, or what should be the value of N for this? See, there are 3 hydrogens which are going to replace each other if I apply a axis and if I rotate it. So that's why N should be 3 for this. So that's why for staggered ethane your point group is going to be D3D. And what about eclipsed ethane? So for eclipsed ethane you don't have to do much work here now, that will be D3H, that's it. Now you guys have to tell me in the comment sections below that what will be the point group for staggered ferrocene, okay. So that part you guys have to tell me, okay. So I'll sum up the video over here. I know, see, whatever we have discussed is for majority of the molecule. There could be a difficult molecule which could be asked in the exam by changing or by making some substitution on it. I will highly recommend to watch detailed classes or detailed videos on point group. I have made it, I'll give you link of that playlist after this video also, that will flash on the screen, so you can watch that, or I will give you in the I button as well. The link will be there in the description as well. So please watch those videos, they are detailed videos on group theory. You will be able to understand all the point groups, how to find out all the problems related to point group will be done after that. So yeah, those are highly recommended. This video is only for those who are afraid of group theory and who are leaving this topic just for the sake that they don't understand it. So at least you will be able to do some questions in the exam. So that's it from my side, guys. Thank you so much for watching, and do let me know in the comment section, should I continue making these type of videos, or you guys want solutions and previous year's question. Do let me know, okay. So that's all from my side. Thank you so much for watching. See you guys in the next one. Till then, have a great day. Bye bye, take care. Hey guys, so I teach live on Unacademy Plus platform. Here I teach for the CSIR-UGC-NET category, and you can follow me over here for regular classes. You can access my free classes as well as my paid classes on this particular platform. The classes which are free, you can get that under the section of special classes, whereas in order to access my paid classes, paid live classes, you have to take Unacademy Plus subscription. So do make sure that you take the Unacademy Plus subscription to access all my paid classes, which are quite organized. The whole syllabus is being completed over there, and the classes are quite regular over there. So make sure that you take Unacademy Plus subscription by using my referral code, that is N_Huda. That's it for this. Thank you so much.